The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right. Today, my objective or objectives, whatever, is to review the first test that we took in here and then the second test, which was chapter 5. If you have any specific questions you'd like me to look at, I will. Otherwise, I'm going to just go through and do some problems from the chapter reviews for the tests. So do you have any questions to start with?
I don't think so.
Okay.
I probably will going though.
Okay, well, if you do, let me know. So what I'm going to do now is I am going to take a look at a question graphing the inequality. This is from section 3.7, which was where our first test was, or was included in our first test. It says graph the inequality x minus y less than -5. We looked at a couple of different ways of doing this. One was to put the inequality in slope-intercept form and graph it that way. The other was to find ordered pairs. I'm going to start out just by finding ordered pairs. So what I'm going to do, I've already written that inequality on my whiteboard, so I'm going to go back there. And I have x minus y less than -5. I'm going to consider the equation x minus y equals -5. Then I'm going to find a couple of ordered pairs. I'm going to go ahead and use the x and y intercepts. Okay, so to find the x-intercept, set y equal to 0. If y is 0, we get x minus 0 equals -5, or x equals -5. So we have the ordered pair -5, 0. To find the y-intercept, we set x equal to 0. We get 0 minus y equals -5. Negative y equals -5. Divide both sides by -1, and y equals 5. So we have the two ordered pairs, -5, 0, and 0, 5. And I'm going to graph that on the WebAssign stuff in just a minute here. But let's see, -5, 0 would be over here, and 0, 5 would be there. This actually is not an equation. It's an inequality, and it doesn't include equals. So we would have a dotted line, okay? Now I'm going to pick a test point. I'm going to pick 0, 0. If I put that into the inequality, I get that which is not true. So this is not a correct test point, so we would shade on the other side of it. Okay? Do you have any questions before I move back to the WebAssign part?
Nope, I remember this one for the most part.
Okay, excellent. So now we're going to turn that into a blue rectangle. We don't want the ray or the line segment. We want the line that has two arrows on both ends. So I'm going to plot the point -5, 0 and 0, 5, which gives me a line. However, we pointed out it doesn't include equals. So I'm going to come over here and make it a dashed line. Then I need to decide whether to shade below it or above it. We tried the test point 0, 0, and it failed. So we want to be above the line. So fill, and there you have it. Any questions about that particular problem?
No.
Okay, let's do another one. This one, I'm going to use slope-intercept form on it. All right, so I have the inequality y less than or equal to -6x. And we'll go back to my whiteboard. This is already in slope-intercept form. So y equals mx plus b. The slope would be -6 and the y-intercept would be 0. Okay, so using that information, I could go back here and say, okay, I need a solid line. The y-intercept is 0. The slope is -6. So I'm going to go down 6 and over 1. Okay, now this is y less than or equal to. Since it includes the equal to, it would be a solid line. Since it says y is less than or equal to -6x, we're going to graph below the line because less than would be below and greater than would be above. So here we go for the fill. Any questions on that problem?
No.
All right, let's go on to, this was out of section 4.5. Here we're solving a system of inequalities, so we're going to graph more than one of them. Let's see, our first one is 5x plus 2y less than 10. And our second one is 2x minus y greater than 2. Do you want me to use the find 2 points method or the slope-intercept method?
The 2 points.
The 2 points. Okay, so let's go to my whiteboard screen. And let's consider 5x plus 2y less than 10. All right, we're actually going to look at the equation 5x plus 2y equals 10. I'm going to go ahead and find two ordered pairs. I don't have to use the x and y intercepts, but they seem to be easy points to use. If you want me to use something different, tell me. Otherwise, I'll go ahead and do this. Okay. So to find the x-intercept, if y is 0, we get 5x plus 2 times 0 equals 10. 5x equals 10. X equals 2. To find the y-intercept, set x equal to 0. 5 times 0 plus 2y equals 10. 2y equals 10, divide by 2, y equals 5. So now we have the two ordered pairs, 2, 0 and 0, 5. So let's graph those 2 points. Okay, 2, 0 and 0, 5. Now, this was for this top equation. No, not the bottom one, the top one. All right. Notice it does not include equals. So our line is going to be dashed. All right. Then we need to pick a test point. Let's again choose 0, 0. 0, 0 is a good test point to choose as long as it's not on the line or the dotted line. Okay. So if we take this inequality and we put in 0, 0, we get 5 times 0 plus 2 times 0, which would be, let's see, 5 times 0 plus 2 times 0 less than 10. 0 is less than 10. That is true. So the point 0, 0 is on in the solution set. Okay. So now, going back here, we're going to fill on that side. Okay. So there's the graph of 5x plus 2y less than 10. Now, let's go back to the whiteboard. And let's take a look at 2x minus y greater than 2. I'm going to consider the equation 2x minus y equals 2. I'm going to look at the x and the y intercepts. If y is 0, I get 2x minus 0 equals 2. 2x equals 2. X equals 1. If x is 0, I get 2 times 0 minus y equals 2. Negative y equals 2. Divide both sides by negative 1, and y equals negative 2. So now I have the 2 points 1, 0, and 0, negative 2. Okay. Let's see here. So I have the point 1, 0, and 0, negative 2. Now, that also does not include equals, so that also would be dashed. Now, I see that somehow I've gotten rid of the fill that I had. Recall that for the first inequality, the fill was down here. It included 0, 0, so it was below this first inequality. Let's take a look at the second inequality, the 2x minus y greater than 2. Okay, so let's go back here. And let's use the test point 0, 0 and put that into the actual inequality. 2 times 0 minus 0 greater than 2. That is not true. So 0, 0 is not a solution to the second inequality. Okay, so what does that mean? So this first one, the fill would be below the line, right? Okay. The second one, it doesn't include 0, 0, so the fill would be over here. So the question is, where's the intersection? Well, the intersection of this and that is just this piece down here. Does that make sense? Do you have any questions there?
No, yeah, that makes sense.
All right. Let's see here. Let's go down and take a look. This is section 14.1. Evaluate the expression, and we have factorials. Remember that exclamation point means factorial. 7 factorial over 5 factorial. Let's go back to the whiteboard. Recall 7 factorial equals 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial equals 5 times 4 times 3 times 2 times 1. But what we can do to make life simpler, let's take 7 factorial over 5 factorial. 7 factorial could be written as 7 times 6 times 5 factorial, because all of that would be 5 factorial. In the denominator, we can just leave 5 factorial. We can then reduce those out, and we've got 7 times 6, which is 42. You all right with that?
Yeah, when we were doing it before and we'd get the higher numbers, these were so hard for me to do. I would just write them all out completely and do it that way.
Oh, that's just awful to have to do all that work.
Yeah.
All right, let's take a look at another one here. This says 7 factorial over 5 factorial times 7 minus 5 factorial. So that would be 7 factorial over 5 factorial. What is 7 minus 5? That's 2 factorial, okay? Well, I could take a 5 factorial out of 7 factorial. So in the numerator, I'm going to write 7 factorial as 7 times 6 times 5 factorial. The denominator, I'm going to write as 5 factorial times 2 factorial would be 2 times 1. Now I can reduce out the 5 factorials on top and bottom. I have 7 times 6 over 2 times 1. I can reduce the 6 and the 2 to 3 and 1, and I end up with 21. We okay with that?
Do you have to reduce those?
Yeah. So if you left it as 42 over 2, that would not be simplified as much as it should be.
Oh, okay, got it.
All righty. Let's take a look at, let's see here. This is taking us to section 14.2. It says, find the first 4 terms of the sequence defined by a sub n equals 4n minus 3. Okay, so this is not the general arithmetic sequence, and it's not the general geometric sequence. It's just a specific sequence that they're giving us. So to find the first 4 terms, we want to find a sub 1, a sub 2, a sub 3, and a sub 4. So again, going back to the whiteboard. So a sub n is 4n minus 3. So a sub 1 would be 4 times 1 minus 3, which is 4 minus 3, which is 1. A sub 2 would be 4 times 2 minus 3, which is 8 minus 3, which is 5. A sub 3 would be 4 times 3 minus 3, which is 12 minus 3, or 9. And a sub 4 is 4 times 4 minus 3, 16 minus 3, which is 13. So there are your first 4 terms. Okay, any questions on that one?
Nope.
Let's see, what did I say? We're in section 14.2, I believe, is where this is. Yeah. Let's take a look at number, let's see here. Yeah, number 10. Okay. It says the first 3 terms of an arithmetic sequence are 3, -3, and -9. Find the first, or find the 101st term. All right, so we've got an arithmetic sequence. The general form for an arithmetic sequence is a sub n equals a sub 1 plus what? N minus 1 times d. D is the common difference. If you take any term in the sequence and you subtract the previous term, you get the common difference. Okay, so let's see here. We're told that the first 3 terms are 3, -3, and -9. So to find the common difference, again, we take any term in the sequence minus the previous term. Let's do this a couple of times. A sub 3 minus a sub 2 would be -9 minus -3, which would be -9 plus 3, which is -6. Let's try this again. A sub 2 minus a sub 1 would be -3 minus 3, which is, yeah, we're getting a common difference of -6. Okay, so D is -6. All right. Now, we're to find the 101st term. So a sub 101 equals, well, let's see. So a sub 101 equals a sub 1, which is 3, plus n minus 1, so 101 minus 1 times the common difference of -6, which is 3 plus 100 times -6, which is 3 plus -600, which would be -597. So a sub 1 is -597. Any question about that?
No.
Okay, let's see how we're doing. Yeah, we've still got a little bit of time here. Let's take a look at number 11. So that's the next one there. Find the common difference D of the arithmetic sequence if the first term is negative 551 and the 23rd term is negative 727. Okay, so we're using an arithmetic sequence, which is a sub n equals a sub 1 plus the quantity n minus 1 times d. We know that a sub 1 is negative 551, and we know that a sub 23 is negative 727, and we want to find d, the common difference. Okay, back to the whiteboard. Let's see here. Well, we know that a sub 1 is negative 551, right? And let's see, we know a sub 23 is negative 727. So a sub 23 would equal a sub 1, which is negative 551, plus n, which is 23, minus 1 times d. So a sub 23 equals negative 551 plus 22d. Okay, so putting that in, I now have an equation involving a sub 23. It's equal to negative 551 plus 22d. But I also know that a sub 23 equals negative 727, because that's given. Well, a sub 23 equals that, but it also equals that. So now I could say negative 551 plus 22d equals negative 727. So we've got our equation. Any question how I did that?
Nope.
All right. So to solve for d, I'm going to add 551 to both sides. 22d equals, let's see, if we take negative 727 plus 551, we get negative 176. Divide both sides by 22, and we get negative 8. So the common difference is negative 8. Any questions about that? Okay, let's go on to number 12. So this number 12 says, find two arithmetic means between 5 and 25. Okay, so that means a sub 1 is 5. I have two arithmetic means, so that means I'm going to find a sub 2 and a sub 3. And a sub 4 is 25. So this is what I know. The first term is 5. Two arithmetic means would be the second and third term. The fourth term is 25. Arithmetic means, right? So it seems to me like if we could find the common difference, we would be in. So this is basically like the last problem at this point. Let's see, is that right? Is that what we did? Yeah. So using a sub n equals a sub 1 plus the quantity n minus 1 times d, we could say that a sub 4 is a sub 1 plus 4 minus 1 times d. A sub 4 is 5 plus 3d. But a sub 4 is also 25. So 5 plus 3d equals 25. So to solve for d, we'll subtract 5. 3d equals 20. Divide by 3, d equals 20 thirds. Okay, so now the common difference is 20 thirds. So if I take a sub 1 and add 20 thirds, I should get a sub 2. And then add 20 thirds, I should get a sub 3. And then add 20 thirds, I should get a sub 4, etc. What I'm going to do, I'm going to leave 20 thirds as that improper fraction. Okay. 5 would be the same thing as 15 thirds. 5 equals 15 thirds. Are you okay with where I got that? I'll take that as a yes. So 15 thirds plus 20 thirds would be 35 thirds for a sub 2. 35 thirds plus 20 thirds would be 55 thirds for a sub 3. 55 thirds plus 20 thirds would be 75 thirds for a sub 4. But 75 thirds is 25, so it checks. So here are my two arithmetic means. And recall that in WebAssign, it doesn't seem to like mixed numbers. So you would use the improper fractions that are given there. Okay? Any questions on that? All right, let's go on and take a look at some geometric, see, find the first geometric sequence. Okay, so number 13, it says, find the find the sixth term of a geometric sequence with a first term of 1/16 and a common ratio of 2. So now we're in section 14.3, and a geometric sequence in general is a sub n equals a sub 1 times r to the n minus 1 power, where r is called the common ratio. So what do we know? We know that a sub 1 is 1/16 and the common ratio is 2. And we want to find a sub 6. Okay, so back to the whiteboard screen. Again, here's the formula for the geometric sequence. We know the first term and the common ratio. We're supposed to find a sub 6. Well, a sub 6 would be a sub 1, which is 1/16, times r, which is 2, raised to the n minus 1 power, which would be the 6 minus 1 power. So a sub 6 is 1/16 times 2 to the 5th power. All right. Now, we could plug that all into our calculator. I'll do that. Let's see, I'm going to go parentheses 1 divided by 16, close it up, times 2 to the 5th power. When I do that, I get 2. Another way I could do this without even using the calculator, you may think this is too much work, but 1/16 would be 1 over 2 to the 4th. 16 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 2 to the 5th over 2 to the 4th, which is 2 to the 1, or just 2. Either way, a sub 6 equals 2. Any questions about that one? Okay, let's go on to the next problem. Write the first 5 terms of the geometric sequence. Let's see, this is number 14. Whose 4th term is 3 and whose 5th term is 3 halves. So we need a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. the fourth term is 3, and the fifth term is 3/2. We're talking about a geometric sequence. So that's a sub n equals a sub 1 times r to the n minus 1 power. Okay. Well, to find the common difference in an arithmetic sequence, you take a term in the sequence minus the previous term. To find a common ratio, you take a term in the sequence divided by the previous term. So r would be a sub 5 divided by a sub 4, which is 3/2 divided by 3, which is 3/2 divided by 3, which is 3/2 times the reciprocal, which is 1/3, and it reduces down to 1/2. So the common ratio is 1/2. Okay. Now, we're going to go backwards. Consider this. If going forwards, we would multiply by the common ratio. So from here to here, we'd go times 1/2. Going backwards, we would divide by 1/2. Does that make sense? Going one direction, you're multiplying, so going the second, you're dividing. So we're going to divide by 1/2. But isn't dividing by 1/2 the same thing as multiplying by 2? Consider this. What's 3/2 times 2? It's 3. What's 3 times 2? 6. 6 times 2? 12. 12 times 2? 24. So there's your first 5 terms. And if you're not convinced, let's go the other direction. If my common ratio is 1/2, meaning I'm going to multiply by 1/2, what's 24 times 1/2? 12. 12 times 1/2. 6. 6 times 1/2. 3. 3 times 1/2. 3/2. Okay. Let's see here. Let's take a look at number 15. It says, find the first term of the geometric sequence if it has a common ratio of -4 and the 9th term is 1024. So we're supposed to find a sub 1. We know that a sub 9 is 1024, and the common ratio is -4. And a sub n equals a sub 1 times r to the n minus 1 power. Okay. Well, we know that a sub 9 equals a sub 1 times r to the 9 minus 1 power, which is a sub 1 times -4 to the 8th power. So a sub 9 equals a sub 1 times -4 to the 8th power. But we also know that a sub 9 equals 1024. So this equals that. There's our equation. A sub 1 times -4 to the 8th power equals 1024. Well, let's see. Let's take the quantity, -4, and raise that to the 8th power. Wow. Well, okay. We'll see here. And that is 65,536. So this would be a sub 1 times 65,536 equals 1024. Well, I'm going to divide both sides by 65,536. So a sub 1 is 1024 over 65,536. Now, if I punch that into my calculator and I go 1024 divided by 65,536, I get 0.015625. But what would that be as a fraction? Well, consider this. 65,536, how did we get that? We took -4 and raised it to the 8th power. Would +4 to the 8th power also be 65,536? It would. So I could think of the bottom as 4 to the 8th power. Well, what about 1024? Let's see, if I divide that by 4, I get, let's see, so 1024 is 4 times 256, which is 4 times 64, which is 4 times 4 times 4 times 16, 4 times 4 times 4 times 4 times 4. Oh, it's 4 to the 5th power. Again, this may seem like a lot of work, but now I could reduce that down to what? 1 over 4 cubed, which is 1 over 64. Okay. And let's see. I think I'm going to now go to chapter 5 because we're running out of time for the day. So let me see here. I want to go back there just a minute. And okay. So this is questions from chapter 5. Remember I said we were going to cover the first chapter test and then the chapter 5 test. So take a look at problem number 1. Consider the polynomial 4x cubed minus x squared plus x plus 10. What is the leading term? It's the highest powered term, right? So it'd be 4x cubed. Any questions about that? All right, let's take a look at problem number 2. It says, simplify the polynomial and write it in descending powers of a. So we've got 7a squared b plus 8 minus 9a cubed b minus 6a squared b plus 4a cubed b plus 3. Okay. Combining like terms, let's see, those go together, and those go together, and those go together. But it's said in descending powers of a. A cubed is the highest power, so minus 9a cubed b plus 4a cubed b would be negative 5a cubed b. And then we've got 7a squared b minus 6a squared b would be plus 1a squared b. Recall that for whatever reason, WebAssign doesn't seem to like you putting a 1 coefficient, even though it's implied. So you don't want to put the 1 in front of the a squared b. And then plus 8 plus 3 would be plus 11. So there is that. Okay. Let's see. I want to go down to problem number 6. So number 6, it says multiply. So we've got negative 6, x to the 5th, z to the 4th, times x to the 6th, z squared. Okay. So that would give us what? Negative 6x to the 5 plus 6 is 11, z to the 4 plus 2, z to the 6. So negative 6, x to the 11th, z to the 6th. Any questions on that? All right, let's take a look at number 7. It says multiply 4/5 h to the 7th power times the quantity 5h to the 15th plus 20h to the 10th. So distributing, we get 4/5 h to the 7th times 5h to the 15th plus 4/5 h to the 7th times 20h to the 10th. The first product, the 5s would reduce out and you'd have 4h to the 7 plus 15 is 22. The second product, 20 over 5 is 4. 4 times 4 is 16. H to the 7 plus 10 is 17th power. Any questions about that? Okay, let's see here. Where's my mouse at? Let's take a look at this situation. We're going to multiply 4x plus 3 times x minus 3. So we're going to FOIL. We get 4x squared minus 12x plus 3x minus 9, which is 4x squared minus 9x minus 9. Okay. Let's see. I want to do another one here. Let's say we have a minus 7, the quantity squared. So that's a minus 7 times a minus 7. It's not a squared minus 7 squared. It doesn't work that way. So foiling this, we get a squared minus 7a minus 49, a squared minus 14a minus 49. How about this one? Negative 28 a squared y over 35 x y cubed. Well, let's see. We could take a 7 out of negative 28 and out of 35. So we get negative 4 over 5. X squared over x would be x on top. And y over y squared would be y squared on the bottom. Y over y cubed, excuse me, would be y squared on the bottom. Any questions there? All right. If we have a polynomial, 6a to the 5th b plus ab squared minus 9b divided by a monomial, 3a squared b. So if we have a polynomial divided by a monomial, we take each term in the numerator and divide it by the term in the denominator. We want to write our answer with positive exponents only. 6 over 3 is 2 over 1. A to the 5th over a squared is a cubed. B over b goes down to 1. So we have 2a cubed times 1, or 2a cubed. All right. Plus a over a squared gives us an a on the bottom. B squared over b gives us a b on top. So b over 3a minus, let's see, is that a 9? Yeah. 9 over 3 is 3. The b's reduce out, and we have minus 3 over a squared. Okay. And that brings us to your favorite topic, which is long division of polynomials. You didn't know that was your favorite topic? Okay. It says divide. Do not use negative exponents in the answer. 2x squared plus 4 plus 9x over x plus 4. So outside, I'm going to have x plus 4. Inside, I'm going to have 2x squared plus 9x plus 4. Notice the dividend inside, I put it in descending powers. Okay. So then we're going to take the leading term inside divided by the leading term outside. 2x squared divided by x is 2x. Then I'm going to take that 2x times the x plus 4 outside and get 2x squared plus 4x, excuse me, plus 8x. 2x squared plus 8x. I'm going to subtract that quantity from what's up above, change it to addition of the opposite. 2x squared plus negative 2x squared is 0. 9x plus negative 8x is 1x. Bring down the next term, plus 4. Leading term divided by leading term, x divided by x is 1. So we get plus 1. 1 times x plus 4 is x plus 4. We'll subtract that from what's up above. We'll change it to addition of the opposite, and we get 0 remainder. So our answer is 2x plus 1. And we're going to take a look at one more here before time runs out. This says divide, do not use negative exponents in the answer. We have 2x plus 1 divided into negative 11x minus 5 plus 4x cubed. All right, so outside we're going to have 2x plus 1. Inside, not only are we going to put it in descending powers, but we're going to fill in a missing power. That is the x squared. So we're going to create a column 0x squared. Okay, so leading term inside divided by leading term outside. 4x cubed divided by 2x, which is 2x squared. We're going to take 2x squared times 2x plus 1, which is 4x cubed plus 2x squared, which goes up here. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. 4x cubed plus negative 4x cubed is 0x cubed. 0x squared plus negative 2x squared is negative 2x squared. We're going to bring down the next term and start over. Leading term divided by leading term. Negative 2x squared divided by 2x is negative or minus x. Negative x times 2x plus 1 is negative 2x squared minus x. Negative 2x squared minus x. We're going to subtract that from what's up above, change it to addition of the opposite, and we get 0x squared negative 10x minus 5. Leading term divided by leading term. Negative 10x divided by 2x is negative 5. Negative 5 times 2x plus 1 is negative 10x minus 5. Oh, and we get 0 remainder. Recall that if you get a remainder, write your answer plus whatever that remainder is over the divisor. All righty. So tomorrow I'm going to be reviewing, let's see, it would be chapter 8 and chapter 9. Okay, so I'm going to stop the recording.